Hello student, welcome to all of you in the next physics lecture. Now we are seeing the chapter number 3, kinetic theory of gas and the radiation. This is the video number 27. Myself, Rajesh Lagat, physics teacher, and we see the next point in that chapter is nothing but the radiation. You've seen the 11th standard, what is meant by the conduction, convection and the radiation. You know that the conduction is nothing but there should be the process in which the heat can be transferred through the material medium without actual migration of the particles and from the one place to another. This is nothing but the conduction, and which occurs mostly in solid. Then we also know that the convection, in this process the heat is transferred through the material medium. That means the material medium is necessary in both conduction and convection, but in that convection the process of heat transfer through the material medium due to the actual migration of the particle, actual motion of the particle from the one medium to the another, and this process is taken in the mostly liquid and the gases. And third one is the radiation we have to see here. The radiation is nothing but this is the process, the heat energy which can be the flows from at the higher temperature to the lower temperature in the form of electromagnetic waves. This is very important. The radiation is nothing but the heat energy which can be the flows from the point at higher temperature to the lower temperature in the form of electromagnetic waves, and which can be travels in a vacuum and no material medium is necessary. And this is due to this radiation is the very vast process to transfer of heat, which can be transferred the heat from one to the another point in the very fast process, rapid process. And so that the heat energy which is propagated in the form of electromagnetic wave, which is called as the radiant energy. This heat energy which can be the propagated in the form of electromagnetic wave, which is nothing but the radiant energy, and we have to study here the radiant energy, how it can be the propagated. Then if this radiant energy which can be the incident on the any surface of the body, then it is used in a three different ways, and these three different ways are as shown in here: reflection, absorption and transmission. That means when the radiant heat energy is incident on the any surface of the body, then it is utilized for the three different purposes. Some amount part of energy which can be the absorbed, some amount of energy which can be the reflect, and the remaining part of the energy which can be the transmit. And therefore this total amount of radiant heat energy, which is nothing but the Q is the total amount of radiant energy which can be utilized for the incident upon the surface of the body. Total amount of radiant heat energy, this is nothing but the Q. And QA, QR and QT be the amount of heat energy which can be utilized for the purposes absorption, reflection and transmission. Therefore we can write here QA, QR and QT be the amount of heat absorbed, reflected and transmitted by the body respectively. Therefore sum of these three, absorption, reflection and transmission of this body incident upon this, which is nothing but the a capital Q, that is the total amount of heat incident upon it. That means QA amount of heat absorbed, QR amount of heat reflect, QT amount of heat transmit, and total amount of these is nothing but the Q, that is the total amount of radiant heat incident upon it. But these energies which can be the absorbed, reflect and transmitted, which cannot be measured, and measurement for this all this radiant heat, we can here use the coefficient of absorption, coefficient of reflection and the coefficient of transmission. You have to ask this exam, define the coefficient of absorption, coefficient of reflection, and the coefficient of transmission. Or sometime you have to show here the A plus R plus T is equal to 1. How it can be get from these three definition: coefficient of absorption, coefficient of reflection, and the coefficient of transmission. First we have to see here the measurement for the absorption. We can use here the coefficient of absorption. What is meant by the coefficient of absorption? Coefficient of absorption is defined as it is the ratio of quantity of radiant heat absorbed by the body to the total quantity of radiant heat incident upon it. Coefficient of absorption, that is denoted by the letter small a, and you have to remember this formula. Small a, this is the coefficient of absorption. A is equal to QA upon Q. That means QA means what? The amount of radiant heat absorbed by the body, and Q means what? Total quantity of radiant heat incident upon it. We have to show here Q, QA, QR, QT. That means A is equal to QA upon Q. This is the coefficient of absorption. From this formula, you can also define this. Coefficient of absorption is defined as the ratio of quantity of radiant heat absorbed by the body to the total quantity of radiant heat incident upon it. This is the coefficient of absorption. A is equal to small a is equal to QA upon Q. Now, second one is the coefficient of reflection, which is denoted by the small letter r. And again, same way, we can define this coefficient of reflection. It is defined as it is the ratio of quantity of radiant heat reflected by the body to the total quantity of radiant heat incident upon it. That means small r is equal to QR upon Q. From this formula also we have to define the coefficient of reflection is defined as the ratio of quantity of radiant heat reflected by the body to the total quantity of radiant heat incident upon it. This is nothing but the coefficient of reflection. And last one is the coefficient of transmission, also which is denoted by the for transmission small t, and small t is equal to QT upon Q. Then this coefficient of transmission is defined as it is the ratio of quantity of radiant heat transmitted by the body to the total quantity of radiant heat incident upon it. This is nothing but the coefficient of transmission, that is small t is equal to QT upon Q. Coefficient of transmission is defined as ratio of quantity of radiant heat transmitted by the body to the total quantity of radiant heat incident upon it. From these three, coefficient of absorption, reflection, and transmission, this amount is always equal to unity, is equal to 1. How it can be shown? We know that the amount of heat quantity absorbed, reflected, and transmitted, this is nothing but the total quantity of amount of radiant heat, that is the capital Q. Therefore, we can write here QA plus QR plus QT is equal to Q, total amount of radiant heat incident upon the body. Therefore, we can dividing throughout this above equation by the Q. This equation we have to dividing throughout by Q. Then see here QA upon Q, QR upon Q plus QT upon Q, and this is equal to Q upon Q. This is nothing but the 1, and we know that by definition QA upon Q, this is nothing but the small a, coefficient of absorption. QR upon Q, this is nothing but the small r, coefficient of reflection, right here small r. Then QT upon Q, this is nothing but the coefficient of transmission, that is the small t. Therefore, A plus R plus T is equal to 1. That is the sum of coefficient of absorption, reflection, and transmission is equal to unity. We have to show here. This is the very important. Define this coefficient of absorption, reflection, and transmission, and the sum of these three coefficient is equal to unity. We have to see here. You have to better understand. Okay, we have to stop here.